This is our 52nd lesson on the biblical flood. We're in chapter 13. We're pretty close to ending this chapter. I think we can finish this material by May, by the time that the class should be over. We'll be pretty close to it. And we'll decide what to do at that time. Okay. And so we'll be looking at it a little bit later. Okay. So now we're continuing in chapter 13 in dating techniques. Now, one of the things we looked at, and I'm not going to go back and rehash it in great detail, but we looked at the what they call the magnetic field of the Earth reversal, or evidence of reversals, the magnetic field. Earlier in this study, I pointed out that if something tries to go in a linear fashion in the physical realm, that would include the mechanical apparatuses, hydraulic apparatuses, pneumatic as a form of hydraulics, and electromagnetic devices. What if it tries to change in a linear form, it creates harmonics. And Fourier analysis, F-O-U-R-I-E-R, Fourier analysis will tell you what's going to be generated. And we pointed out that one of the claims is that the magnetic field of the Earth is decaying in a linear fashion. And if that's true, then we've got a problem. We should have been generating harmonics. And if harmonics were being generated, then they would show up and appear as magnetic field reversals. And so again, if they're right about it being linear, then this evidence of magnetic field reversals could have come from that. There's another possibility where they could have come from. And of course, then the dating of them, I think they could have occurred when there was interaction between what I believe to be the planet that caused the primary cause of the flood, that is the breaking up of the fountains of the deep, but I think it was planet Mercury, magnetic field's interaction with the Earth's magnetic field. But what we have here is these interactions could have caused the apparent reversals. Of course, all of this discussion of it is based upon the assumptions of uniformitarian principles. And so we've seen this already. And so they've rejected uniformitarianism, but they still use uniformitarianism to date things. I think that's shows that they're either not thinking clearly, or they're not being rational, or they're not being honest, one of the three. Sedimentary rocks were dated by the radiometric technique. The dates of the field reversals, fields, were calibrated by the radiometric dating techniques. So they calibrated these field reversals by radiometric dating techniques. By radiometric, we're talking about the decay of radioactive isotopes. And of course, that's their basic dating. Cox tells us, and again, this is all in the book, however, after being calibrated against known points on a radiometric timescale for reversals, the profiles provide a nearly continuous record of polarity intervals. So all of this dating of these magnetic field reversals are based upon radiometric timescales and radiometric dating techniques. And of course, we've already seen radiometric decay has 4 variables in the equation. They only know one of them for certain, and that's how much they have at this time. And we've shown that there's some evidence that at least some of the radiometric decay constants, the constants for the decay, and it was lambda in our equation, that these have been known to be varied by temperature, pressure, and other factors. And of course, radioactive decay is sometimes triggered by neutrinos. And so it's possible an influx of a large number of neutrinos could have triggered them and made them appear, made them change much more quickly than they was thought to have decayed. So it would greatly speed up and make the time functions look longer than they really were. There's other factors, unknown factors. We don't even know what else might have affected them. Right. Radiometric dating was used to date human bones, that is the skull in China. Tamel, he says, our early work in U series, that'd be uranium series dating, assigned the age range of 230 to 300 kiloyear, that 1,000. That'd be 230 to 300,000 years to layers to the layer 6 where the skull was found. So they dated the material where the layer of soil where the skull was found by radiometric dating as the uranium series. The layer of soil was dated by radiometric dating techniques, and the skull was dated by the layer of the soil which it was found. Now, that's not terribly unreasonable, although the skull could have been buried, and someone might have buried the skull as we bury people. So if they found my bones or the bones of my grandfather or someone like that, they may look at those bones and say, well, it's in soil, it's dated such and such, and so must have lived at that time. And again, it could have been put in that soil on purpose later, at a later time. Radiometric dating was used to date the teeth and jaw fragments from Spain. And so we have fragments of people in Spain. Holden makes the following interesting statement. I find this interesting. Holden says, Andy Current of London's Natural History Museum warns that it will be difficult to pin down a date. And he says uranium dating becomes unreliable beyond 300,000 years. I find that somewhat interesting, but we won't go any further. How did they date glaciers? Now, Denton and Hendy tell us in pages 1434 through 1437 that they used radiometric dating to date the time of the glaciers. And so they dated it by radiometric dating. Now, most of that's probably going to be carbon-14. Most of that will be. Two different ice cores were drilled in the Greenland ice caps in 1992 by two groups of scientists, one group from Europe and another group from the United States. And so they got, as they were looking at these layers, and he says, we'll see more of this on the next slide, bleary-eyed after counting and recounting 15,000 layers. So they had to count 15,000 layers of the ice. They discovered that the climate shifts occurred in less than a decade. So there was a shift in the climate that occurred, a drastic shift in climate. So climate change occurred, according to this, in less than a decade. And so that's very interesting that would occur so rapidly, that the shifts occurred approximately 1,000 years earlier than previously estimated from ice cores. So we had to redate everything with our system. Although such layer counting has a credibility problem, I want you to notice that. Fairbanks admits that the layer counting has a credibility problem. Now, when you start counting layers, we're going to see why they had trouble with it in just a moment. At the summit site, Alley et al., Alley and others, were able to circumvent difficulties that plagued other ice core sites. So we can circumvent that. How do we do it? With 14C, that's carbon-14, that's radiocarbon timescale. Over the glacial period has been calibrated recently using uranium and 14C. That's uranium and carbon-14, radiocarbon, measured in corals and extended 14C tree ring chronologies. So we've gone back and measured it and looked at tree ring chronology. So again, now what they're doing, they're using tree rings to date the carbon-14 and use carbon-14 to date the tree rings. And of course, again, your radiometric dating has this problem. They have to assume how much of the material, the radioactive isotope they had at the beginning when that was deposited, when that, in this case, when the ice was deposited or when the tree was living. So they have to make assumptions about that. And of course, we saw all the problems with radiocarbon dating that we have seen earlier. So again, there were difficulties, and so they solved it by using radiometric dating. They calibrated it using uranium and carbon-14. Carbon-14 is radioactive carbon, radioactive isotope of carbon. Fairbanks is asserting that radiometric dating was used, probably referring to the European ice core, as my study showed. Alley et al. Claimed that isotopes, now we'll explain what that is, elements such as, let's use carbon as an illustration. Most carbon is carbon-12, and it has 6 protons and 6 neutrons in the nucleus. And normally, unless it's ionized, it'll have 6 electrons. And so that's normal. Most carbon is that. There are some carbon atoms that are carbon-13. They have 6 protons. That's what makes them carbon. And they have 7 neutrons. Now that's carbon-13. It's stable. It doesn't decay radiometrically. But of course, it has 6 electrons. Normally, it's ionized. So right here, the isotopes here, they use them to date. And were only used for the first 300 years of the dating. So they're using radiometric, they're using isotopes to date it. Now we're going to look at this. It was only used for the first 300 years of the dating. That's interesting, only for the first 300 years. They list dust layers as the dating techniques to the remainder of the ice. So they looked at dust layers. So they went and found dust from various volcanoes that had erupted and had settled on the ice. And they used this to date it. And the dust from different volcanoes will have different content. And this is part of how they did this dating. Of course, now then they've got to know when that volcano erupted. And it goes right back to radiometric dating to figure out when the volcano erupted, unless they have strict information such as something erupted 2,500 years ago. But if you go back in time, like 10 or 12,000 years, as they are prone to do, they have a problem with it. They can't get it from human history. They have to get it from other sources, and I always goes back to radiometric dating. Alley lists radiometric dating for the European ice core at other depths, page 529. In addition, they're making uniformitarian assumptions that the rate of the snow falling that supposedly caused the glaciers to form. We've already seen problems with glaciers where it gets real cold forming. There's just not much snow that occurs in Antarctica, for example. It's one of the driest places on the earth because the cold just takes all of the moisture out of the air. Substantive uniformitarianism has been rejected, but they're using it and assuming the snow fell at a constant rate. And that's the assumption. Of course, they've completely ruled out the possibility of my flood model. Of course, many believers in the flood reject my flood model, or at least they haven't considered it. Okay. There's no doubt that snowfall forms some glaciers. I think there's some evidence of that, mountain glaciers, for example, at the present time. But this does not prove that glaciers of continental proportions were formed by this mechanism. And one of the problems you get into when you take moisture across a glacier, when it starts across the edge of the glacier, it will lose its moisture and then it will become dry as it moves inland. And that's exactly what we can see here. Once the moisture is taken out of the air, there's no place to get any more moisture to replenish it. So we would have places like on the west coast of the United States, if it goes up the Sierra Nevada mountains, it snows on the west side and it's pretty dry on the east side of those mountains after the moisture has been taken out as it goes uphill up the slope. And of course, as your glaciers got higher, that would make it go uphill and go upslope and lose on the west side as it moved from west to east. As a lot of the air masses move in that direction, they would lose their moisture on the west side. So the west side of the glacier would be higher than the east side. But there'd be other problems. You would have continental glaciers several thousand feet thick. Certainly, snow does contribute to the thickness of the glaciers in Greenland in some way, but I would argue that the contribution is probably minimal contribution. As one goes deeper into the ice caps, it becomes increasingly difficult to discern annual rings. That's the problem. And so they assume every layer is an annual ring. So they count the number of layers, and that's how many they get. Now, then, there are air bubbles in ice. Some of the ice provide information on the gaseous composition of the atmosphere at the time the bubbles were formed. So if these air bubbles are there, you can take the air in there and find out what the composition of the atmosphere was. The upper parts of the ice sheet, annual layers can be identified according to this source that I have here. This is Hartmann. Deeper into the ice and thus further back in time, the ice becomes compacted and stretched out as the ice flows away from the accumulation regions toward the regions where the ice sheet melts or breaks off into icebergs at a marine boundary. And so this is called calving of icebergs. So what we have here is these layers become compacted and stretched out. That's why they have trouble figuring out how many layers they actually have. So the layers become compacted and they become stretched, and so they're very, very thin. And so it's real difficult to count them. No doubt that some of the so-called annual layers were deposited by the snow that fell in the last 400 to 4,500 years since the flood. No doubt about that. But some of this dating is done by the ratios of one isotope, stable isotope, to another of an element, such as oxygen in the air bubbles. So we'll get back to that in just a minute, and also in the ice itself. Oxygen 16 and oxygen 18 are both stable because of the greater mass of oxygen 18. That is, it has 18 particles in the nucleus versus oxygen 16 with only 16 particles. And it will tend to concentrate in lower levels of hydrosphere, water sphere, and atmosphere. So the water in the lower parts of a lake or an ocean will have more oxygen 18 than water at the top of it would have. And so what they're doing is they're looking at the oxygen 16 and oxygen 18 and those ratios just to give them some more information. But it's dangerous, if not erroneous, to use these ratios when the impact of cosmic ice would change the ratios of these isotopes. And my flood model would have cosmic ice coming in, would have different ratios of these isotopes. So using these ratios assumes that this ice all come from the Earth, that it wasn't cosmic ice. Assumption that make. Sue, HSU, Sue states, a large amount of cometary carbon should also significantly alter the isotopic composition of calcareous sediments in the ocean. So large amounts of cometary carbon would change it. The isotopic composition of carbon for meteorites and for the Earth's mantle has about the same composition of -6 to 7 per thousand. Now then, this is not percent. This marker is per thousand, and 13C. That's carbon 13. So what we have this ratio. However, the carbonate in meteorite and carbon in chondrite, now these are types of meteorites, have very heavy 13C with values more than 50 per thousand. So we had about 6 or 7 per thousand normally, but we have 50 per thousand. So the carbon, the amount of carbon-13 in meteorites, chondrite meteorites and other type meteorites, carbon and meteorite and the carbon and chondrite, have a very heavy carbon-13. And the nucleus of the comet may have represented a distilled fraction. That is, the heavy stayed with the comet and the lighter was distilled off due to, as it come close to the sun or some star, in our case it'd be the sun, the heat would cause the lighter carbon to be accelerated away and it would be lost to the comet. So it would have the heavier carbon in it. Should have an isotopic composition much lighter than that of the average meteorite. So if you get meteorites or something coming from space, you're going to have a different ratio of these isotopes. And that would apply also to oxygen isotopes as well. Birchfield admits that radiometric dating is the only method used by uniformitarian geologists. Now, he admits it. When it's all said and done, it all goes back to radiometric, which again, we pointed out, they've got 4 variables in the massive formula, and they know one of them with pretty good certainty. We'll just give them that point. And there's some question about the decay rate, decay constant, and they don't know with any certainty at all how much of the material they had at the beginning. And they have to make an assumption of it in order to solve for the time, the 4th variable. Again, it's all based upon an assumption. You can take any assumption you want of how much you had to begin with and get any value of time you want with this. Under the heading of measuring the age of the Earth, Birchfield states, well, however, the problem always reduced to one of finding a reliable geologic or cosmic clock. Phenomena had to be identified that could be readily quantified and measured, which could be shown to vary regularly with time. Today, the decay of radioactive elements is universally regarded as the only phenomena which meets these criteria. But again, they've got a problem. Remember, it's got 4 variables in the formula. They only know one of them with certainty. And they assume they know 2 of them, the decay rate. But they've still got the problem of how much they had at the beginning. And so they've got to make an assumption. It's all based on assumptions. This implies that radiometric dating is the only game in town for the atheist when he dates things. There's no other game. Why is it so important? Lord Kelvin, which we got a Kelvin Tempter scale, assumed that Earth began as molten rock and calculated the age of the Earth from the time required to lower the temperature of the molten rock to their present temperature. Now, Birchfield talks about this on pages 6 through 7. Allegre states, Kelvin estimated the time it took to cool the terrestrial surface from 2,000 degrees Celsius or 1,000 degrees Celsius to today's 25 degrees Celsius, taking account of the heat flow that the Earth generates. The resulting figure was 100 million years. So he came up with, if it started out as molten rock, then it would have taken 100 million years to cool off to the rate that it has now, which agreed with the result of the similar calculation he had made for the sun. All right? He therefore concluded the Earth and the sun were formed at the same time about 100 million years ago. Now again, he's making this assumption it began as molten rock and that the sun began away. But around 1880, Craig and Carl Barris' first precise measurements of the thermal conductivity of rocks led them to reevaluate the heat flow and to lean toward the short chronology. They estimated the age of the Earth at 25 million years, and Kelvin went over to their position. So now we've downgraded it from 100 million to 25 million years. And of course, that's assuming it started out as molten rock and wasn't cooled off by God in his creation. And of course, that's assuming there's no God. With the discovery of radiation, the atheist who must have an Earth of several billion years old, began to claim it must have large amounts of radioactive material in the interior because it's over 4 billion years old. So it's 4 billion years old, so something's kept it hot. The only thing that we can think of is radioactive materials. So that's what it must be. The basic argument of the atheist begs the question. It's 4 billion years old, therefore there has to be radioactive material there. That's how we know radioactive material is there, because it's 4 billion years old, 4.5 or whatever. And so we know it's that old, so it has to have radioactive material, because otherwise it wouldn't stay hot, as warm as it is. It would have cooled off even more. So there must be radioactive material down there. Have they dug down and measured it? Absolutely not. Absolutely not. They haven't. We'll see some other problems with it too. They assume the Earth is over 4 billion years old in order to determine that there are large amounts of radioactive materials in the interior of the Earth. Then use that assumption to prove the radioactive materials are in the Earth, and turn around and say the radioactive material is there, and so we know it's 4.5 billion years old. That's why we know it. That's circular reasoning. That begs the question, what evidence do they have for there being enough radioactive material in the interior of the Earth to keep the core of the Earth molten for 4.5 billion years? They don't. There's no evidence. Atheists admit they're just theorizing that this radioactive material exists. So when they respond about the flow of heat from Kelvin's calculations, they have to have this radioactive material. It must exist, otherwise the Earth is no more than 25 million years old, and that's assuming it started out as molten rock and was allowed to cool off with natural means. One group of atheists says, in the mantle, the source is probably, notice the word probably, the radioactive disintegration of long-lived isotopes. That's probably. Notice how they say probably, indicating that they cannot prove this assertion. And again, their whole system depends upon this. If they're wrong on this, they're wrong on the age of the Earth. It can't be more than 25 million years old. That's assuming it was allowed to cool off by natural means, strictly naturalistic means. That there was no God involved in this action of the creation. In the beginning, God created the heavens and the earth. And see, we don't have to worry with it as Christians because we know God did it. Notice how they say probably, indicating that they cannot prove this assertion, yet it is essential to their claim that of the age of the earth is that it's 4.5 billion years old. Now, Hapgood tells us, now remember, Hapgood's book was endorsed by Albert Einstein. He wrote the preface to it, so be aware of that. So Hapgood, he had pretty good endorsement. I think some other people endorsed it as well. I have his books, two of his books. The Earth's heat, unfortunately, is another mystery. He says, no, I'm not Hapgood. I don't know that Hapgood was a believer in God. I think he might have been an atheist. Formerly, it was thought that it originated with the planet and was greatest at the Earth's core. Now it's thought that most of the heat originates from the decay of radioactive materials in the lithosphere, and very little comes from the greater depths. Isn't that interesting? That's what it's thought. We have no direct evidence that can settle this matter, so we can't settle it. There's no evidence that we have where we can settle this and answer this question. It's quite possible that the heat gradient we observe in deep mines, on which our estimates are based, does not extend all the way to the Earth's center. If this is true, it would pull the rug out from under many of our ideas. Again, we just don't know. And again, we see all kinds of places where they're not aware. They don't have evidence. And they're groping and they're assuming. It's based upon one assumption right after another. Hapgood is saying that the old Earth theory demands that the heat not increase with depth. It demands that it shouldn't increase with depth. I can't understand why heat wouldn't move from the top down to the bottom, and the center part of it would be hotter than the outer portion. That makes sense. but I'm not a thermodynamics expert. I've had some and enough to know it should have flowed pretty well equally throughout all of it, and it should have flowed. The inner portion should have been hotter than the outer portion. One problem with the claim that radioactive isotopes cause the heat is the question of where these isotopes are located. Now, notice they're in the core of the Earth, or they're in the lithosphere, the outer layer. Well, the claim is they're in the lithosphere. Of course, lithos is the Greek word for stone or a stone, but the lithosphere. Why are heavy elements in the outer core, crust of the Earth, and not in the core of the Earth? Why are heavy elements like uranium, why didn't they settle into the inner part of the Earth rather than the outer part of the Earth? Thorium and radium and uranium and so forth. Why aren't they? They should sink in the molten rock, and lighter elements should rise from Archimedes' principle. That's what we normally would see. But we're not seeing that if they're right about their dating system. These radioactive isotopes are confined to the crust and lithosphere. How is convection current of magma able to move the continents apart? They've got a problem there because these radioactive isotopes are very heavy. How would that occur? How can the convection currents bring heat from the core of the Earth when the heat is being generated by the isotopes in the lithosphere, which is higher than the core? Now, let me ask you a question here. When you study heat in general physical science or maybe a physics class, heat moves in basically three manners or ways. By conduction, that is, molecules transfer kinetic energy movement from one molecule to another. By conduction, by hitting or touching one another, transferring that kinetic energy. Another way is by radiation. That's by electromagnetic waves. A lot of that would be heat, which is a form of it. And so we have infrared as one of the types of heat, but different sources, different heat waves, and that will be radiation. And then we have convection. That's where the material that's warm moves from one place to another. If you have a heater on one side of the room, I remember when I was in college, they had steam heat in the place where I stayed, the dormitory. And whenever they had this steam heat, the heater would get warm on one side, the hot air would rise and go to the ceiling and move across the ceiling, and the molecules that were a little bit cooler would settle down, and they would heat the whole room from one side of the room to the other. And then the air would move along this opposite wall and come back in, this cooler air, going back to the radiator, and it would cycle through. And that's called convection current. Well, the heat of the core of the Earth is the material in the lithosphere moving by convection current. If that's how it occurs, is that how we get the movement of the plate tectonics? See, that's the assumption. But our problem is the heavier stuff. If you study convection currents, when the hot air rises, the energetic molecules, the ones that are moving the most, they push others apart and the air gets less dense at the top of the room. And the slower moving molecules then will settle down as they move downward. And they transfer, they're warmer than the air, they're more energetic than the ones above them. So they transfer their energy, and eventually they bounce around and lose kinetic energy and wind up down to the floor. And that's exactly what we see here. We should have had these heavy molecules. In this case, it's not just kinetic energy, it's the molecules are heavier. These isotopes of uranium is a very heavy element. And so it should have settled down deep into the Earth rather than be up in the lithosphere. This flies in the face of physical processes that cause convection currents. That's a problem for them. Again, It just flies in the face of these convection currents. Another problem with the claim that radioactive isotopes cause the heat is, in the Earth, pointed out by Kennedy. Kennedy had some pretty good points in his article, and it was published by one of the high-powered journals, remember that. Insomuch as radioactive heat-producing elements are associated with sialic rocks, one might expect heat flow through the thicker parts of the Earth's crust to be greater than through the thinner parts of the Earth's crust. However, as a first approximation, heat flows through the crust of the Earth approximately the same through the continents, mountain ranges, and ocean basins. That's interesting. Shouldn't be. It ought to transfer at a different rate through those areas, but it's approximately the same. Now then, let's look at sediment deposition rates, radiometric dating. The major sedimentary deposition rates of the oceans invalidates radiometric dating. I'll show this here. Two of the basic assumptions of radiometric dating, that both the parent and daughter isotopes have not been disturbed, are untrue. Our problem is, we're going to see this. The parent isotope is what the isotope we had at the beginning, like carbon-14. The daughter isotope would be with carbon-14, it would turn back into nitrogen. Okay, so that's what we run into. Some of your other ones, like uranium, will go through other elements, become other elements, just like carbon-14 does. So the daughter isotope is what's generated as a result of radioactive decay. Now, the problem is, Judson states that insomuch as we have been talking about the sedimentary aspects of the rock cycle, we should ask how much it takes to complete at least the sedimentary route within the whole cycle. So how long does it take sedimentary rocks to cycle and recycle, and we get the recycling of these rocks? Polar art gives the total mass of sediments, including the sedimentary rocks, as 1.7 times 10 to the 18th tons. Now what that is, if you take this decimal point between the 1 and the 7 and move it to the right 18 places, that would be how many tons he's talking about there are. That would be your number. That's what you got to do to get that mathematically. Taking the annual production of sediments, or 10 to the 10th, that's a 1 with 10 zeros after it. Then one turn of the sedimentary cycle approximates 1.7 times 10 to the 8th, and that would be 1.7, and move the decimal point 8 places to the right years. Now 10 to the 9th is a billion years, so that's 170 million years. At the present rates, then, we could fit in about 25 such cycles during the 4.5 billion years of Earth history. In other words, the sedimentary rocks should have been recycled 25 times at the rate we see. So we shouldn't have any sedimentary rocks. They would all been recycled 25 times. Shouldn't be any of them that would be anywhere near a billion years old. What Judson is saying is that sedimentary rocks could have been recycled at least 25 times during Earth's history. If Judson's calculations are correct, these rocks should be recycled in 170 million years. Now, advocates of plate tectonics claim these rocks are recycled by subduction. That's what they claim. Now we've got a problem. How is it possible to have sedimentary rocks that are over a billion years old when they're recycled every 170 million years? At the present rate, using uniformitarian techniques, assumptions. These are all based on uniformitarian assumptions. The atheists have made ad hoc assumptions, that is, assumptions before they have any evidence. This reveals one of the contradictions of atheistic dating methods. They have serious problems with this. Even 170 million years is based upon substantive uniformitarianism, which has been rejected by many atheistic geologists. Again, they get into trouble. They can't get away from it. They keep coming back to uniformitarianism. Because if they don't have uniformitarianism, the Earth has to be younger and younger. Remember, it's 107 million years based on substantive uniformitarianism is the maximum age one should expect for sedimentary rocks to have. Shouldn't be any sedimentary rocks. Shouldn't be any fossils over 170 million years old. Even if it's assumed that the whole crust of the Earth's been recycled, it would have occurred twice in 4.5 billion years. Shouldn't find any rocks older than about 2.25 billion years old. The whole crust of the Earth would have been recycled. Accepting Polaroid's figure of 2.4 times 10 to the 19th tons as the mass of the Earth's crust, and there has been time enough for a mass equivalent of the Earth's crust to have moved 2 times through the sedimentary portion of the cycle, Judson tells us. So the whole crust of the Earth, we shouldn't be able to find any rocks older than 2.4 billion years. 2.25 billion years, half of 4.5. And they claim they have rocks older than that. If the entire crust of the Earth has been recycled at least twice, it'd be impossible to find any rocks that are over 2.25 billion years old. Now, notice this, if you will. We have serious problems with atheistic views. Now, we're going to give some more information about this, but our problem with it is we've already seen some other factors. We'll point these out at a later time. Now, do you have any questions? Anybody? Or comments?